Okay, for this practical, if you read the description, this would match the description for flame test. Okay, and how do you know? If you refer to your notes, flame test, you read the description exactly the same. It's on page 11. So flame test means you want to see the color of the flame. So you have to describe it as green. A green flame is observed, and green will tell you it's a copper 2 ion. Lilac or violet flame is observed. This will tell you it's potassium ion. So from this flame test, we can tell which cation is it. And if it's a yellow or orange flame is observed, it is sodium ion. When you do flame test, you always expect to see a color. Okay, next, when you add magnesium ribbon, which is a metal, it's either it could be a metal reaction with acid to get salt and hydrogen gas, so you may see any effervescence, or if it's a metal, it could be displacement reaction where a more reactive metal displaces a less reactive metal from the salt solution. So let's see what we get with this test for P. So this is solution P. So we saw a red-brown precipitate or deposit. As long as you see a reddish-brown solid, it's likely copper. And because copper 2 solution will be blue, so as it's being displaced, you will see that the blue color becomes lighter or turns totally colorless. It depends, okay? So in this case, it did not turn completely colorless. So what has happened is the magnesium, which is more reactive than copper, has displaced copper from its solution. For solution Q and R as well, there is no visible reaction. No visible reaction means there was no displacement taking place, which means likely this magnesium could not displace um, the metal in Q and R. So magnesium must be less reactive. Okay, so here I'm writing that metal in Q and R is more reactive than magnesium, which is why magnesium metal cannot displace it. Okay, so next one, this test, if you read the description, is a test for anion, which is chloride ion. So if you look at your practical sheet that's given to you, you will see there is chloride ion. And if chloride ion is present, you will see a white precipitate. Okay, so that is what you should observe. White precipitate is formed. So let's see. For P, okay, the next thing before P is that if you add acid, there could also be reaction of acid, which is metal or metal carbonate, which means there could be effervescence. So here is a white precipitate is formed. That's it. So with this, likely it means that chloride ion could be present. So now we have a gas of the anion in P. Okay, the next one, if you realize the color is not really white, but it's a slightly white precipitate. So this you're not expected to know, but for information as well, it could be bromide ion. So the more you do more practicals, the more you recognize that bromide ion could be this color. And finally, because it is a reaction, there's acid added, it could be a reaction of acid with perhaps metal carbonate. So there's effervescence, and here there's also a white precipitate observed. Okay, so in this case, we know that these are the observations that we see. So we are not sure if there is chloride ion in this, as we also see effervescence. So we just think that it could be a metal carbonate. reacting with an acid to get the effervescence. Okay, so we're not quite sure why there's a white precipitate, whether it's a chloride ion or whether it's a case of soluble salts reacting with soluble salts to getting an insoluble salt, which appears as a precipitate. Okay, but this is just a guess. You do not need to know this, but it's just a guess that this may be the one happening. So now you look at the next part where we add aqueous ammonia. So aqueous ammonia is a test for cation. In this case, it doesn't say anything about adding continuously until no further change, which means you don't have to say anything about whether is it soluble or insoluble in excess. So for the first one, P, a blue precipitate is formed. So blue PPT tells you there is copper 2 ion. So this is confirmed in the flame test, confirmed in the displacement, and now um, shows you that it's accurate in this cation test. Okay, and then for both Q and R, there is no visible change, no visible reaction. Or for Q, some of you will say that there is some white precipitate remain which was coming from the above. Okay, so it's not that there was white precipitate produced, but it was the slightly white precipitate formed at the previous test. So since Q and R has no visible change or no visible reaction, again it's likely sodium or potassium ion. This identity was also shown in the flame test. Okay, for part D, this is the same as the test for sulfate ion. So instead of nitric acid and barium nitrate, they are using hydrochloric acid again to acidify and barium chloride because it will still form barium sulfate, an insoluble salt, if sulfate ion is present. Again, since we're adding acid, there could be any form of effervescence. Okay, so for P, Q, there is no visible reaction. So for our own recording, we can put that no sulfate ion is present. And for the last one R, we see effervescence again with acid. So again, we are guessing that it could be perhaps a metal carbonate. But we cannot conclude that it's a metal carbonate because there is no test for the carbonate ion. Okay, so finally, for our conclusions, it says look at part A to D, draw conclusions about salt PQR and the ions they contain. So based on the displacement reaction, we could conclude about the reactivity, or we can conclude even about copper ion being in this test. The next conclusion can be about chloride ion, because white PPT was formed for part C. Conclusion 3, because of the cation test, which is very clear, copper 2 ion is present. Or other conclusions that were not written here could be from the flame test, which is part A, where you can conclude the different cations. Okay, we cannot say anything about sulfate ion because sulfate ion is absent. They're asking you for what ion is present.